Okay, so customer downloads a new educational software package from the company. Explain how the customer's computer and the company's computer use a hashing algorithm to make sure that the software has come from the company itself. So you want to authenticate the company. You want to make sure that the company is genuine, right? That's one thing that you want to do. Make sure that the sender is genuine, right? And you also want to make sure that no one has changed the software. So this basically is a situation, right? So we have the company server, right? So let this be the company server, right? And then you have the internet. This is connected to the internet, and the customer computer is also, so this is your customer computer, right? And this is also connected to the internet, right? And you're downloading this software from the internet to the customer's computer. Now you want to make sure that the sender is genuine, that the sender is the company itself. And you also want to make sure that whilst this software was traveling across the internet, the hacker, if there was a hacker, if he intercepted and if he changed the software, if he changed or altered it in some way, right? If he changed it, then you want to make sure that you find out if the software has been changed, right? So this, if something like this has happened, you should be able to know, you should be able to find out somehow that somebody has altered the software. So these are the two things that you want to verify. These are the two things that you want to do. One of them is to authenticate the sender, that the sender is the company itself, and the second is whether the software was modified or not, right? If this is the original copy or did somebody modify this copy. Okay, so just remember this. As far as authentication is concerned, as far as you want to make sure that the sender is genuine, right? For authentication, the technique used, and this is where you're making sure that the sender is genuine, right? The technique used is called digital signature. Okay, and a digital signature, just like the name suggests, is a technique that is used to verify the sender, right? Just like when you walk into a bank, right? The bank takes your signature before you are able to withdraw cash, right? They verify your signature. On the internet, the technique used to verify a sender is called digital signature. Okay, and let me give you some other scenarios. Like, for example, the government of Pakistan sends an email saying that it's going to be a holiday on the 5th of June, for example, right? So you want to make sure, so different departments receive this email, but you want to make sure that the sender of the email is the government of Pakistan, right? You want to make sure that it is not somebody who has on purpose mischievously sent this email. You want to make sure that the sender is genuine, right? So in that case also you'll need to do some authentication. Okay, now how do we authenticate? See, the technique to authenticate uses digital signature, and in digital signature two keys are used. One of the keys is called the private key and the other key is called the public key. Now both of these keys belong to the sender. So you use the sender's private key and the sender's public key. So both keys belong to the sender. Okay. Just remember this, that the sender will never share his own private key with you. So the private key is always used by the sender himself. So the sender is never going to give anybody else his own private key. So when the government of Pakistan sends an email, it will never share its own private key with anyone. It will use its private key on its own, but it will give its public key. So the public key is something that can be given to everybody else. So these departments can have the public key of the government of Pakistan. So how do they get the public key? See, the public key of the sender is available through something that is called a digital certificate. So what can happen is that this department can download the digital certificate of government of Pakistan from the government of Pakistan's website. So the department can download the digital certificate of the government of Pakistan from the government of Pakistan's website. So that's one way of downloading the digital certificate. Once you have the digital certificate of government of Pakistan, you can have the public key of the government of Pakistan, because that public key is part of the digital certificate. Okay. So that's one of the ways that this department can acquire government of Pakistan's digital certificate, right? You can download it from government of Pakistan's website. There are other reliable websites also. So there are other companies, well-known companies, trusted companies, internationally known companies, that this department can contact this company rather than going to government of Pakistan's website. This department can contact this company, right, and it can ask this company to give it back the digital certificate of government of Pakistan, right? So these well-known trusted companies have a copy of the digital certificate of government of Pakistan. So the computer can either download it from this server that belongs to a third party, well-known companies that are providing these services. You can download it from a third party, and that way you can acquire government of Pakistan's digital certificate, or you can directly download it from the government of Pakistan's website itself. Okay, so let's go back to understanding how authentication is done. Okay, so what we said is authentication, making sure that the sender is genuine, right, can be done using digital certificate, right? It can be done using digital signature, and in digital signature, one of the components is the private key that is available to the sender, right, and this the sender does not share with anyone. And the other component is the public key that is available to the receiver. Public key is available to, and this public key belongs to the sender also. So this is available to receiver through digital certificate, right? So the receiver can get hold of the public key of the sender by downloading the digital certificate. Okay, and part of the digital certificate is the public key, right? Okay, so how does this work? First, let's take a look at what's happening at the sender's computer or the sender's server, right? Well, you have the software available to you. You pass the software and you apply a hashing algorithm on it. So you pass the software through a hashing function, and this is where you get a hashed value for software, right? Remember, what you had originally was the software. You put it through a hash function. The hash function is going to compute a hash value for the entire software, right? And that hashed value, the hash value that you just computed, is called a digest. Okay, so the software has been put through a hashing algorithm, and what you have now is a hashed value for this software, right? And this hash value is technically called a digest, right? Once you have the digest available with you, once you have the hashed value available with you, in other words, you're going to encrypt. This is the next step. You're going to encrypt this hashed value, this digest. You're going to encrypt this digest, and to encrypt this digest, the sender uses his own private key. Remember, the sender is never going to share his private key with anyone. So the sender is going to encrypt this digest using his own private key. Once this digest has been encrypted, or this hashed value has been encrypted, now you have something called a digital signature. So in other words, a digital signature is basically the encrypted hash value, right? Remember, this is where you had the hash value and then you encrypted it. So what you get is basically the encrypted hash value, and a digital signature is called the encrypted hash value. So the sender's computer now has the encrypted hash value, and it is now going to send this encrypted hash value, right? It is now going to send this over the network. So it's going to send it over the internet to the receiver, right, to the customer computer, and this is where we're going to take a look at what is going to happen at the customer side now. Okay, so this sender's computer is sending two things, right? I forgot to mention that. One of the things it is sending is the digital signature, right? That is the encrypted hash value of the software. So it's sending the digital signature, right? And the second thing that is being downloaded is the software itself. So essentially the sender is sending two things. One, the software that you want to download, and the other is the digital signature. And now both of these are being received. Both of these have been received by the receiver. So now we are at the receiver side, right? And the receiver has received two things. It has received the software that it wanted to download, and it has also received the digital signature. Okay, so let's see what the receiver does with these two things. Okay, now remember this, that the receiver has the public key of the sender through the digital certificate, right? It downloaded. Okay, let's see. The software that the receiver receives, the receiver, and remember this is the software, and the receiver, what it does is it applies the same hash function that the sender applied. Okay, so the software that was received by the receiver is going to apply the same hash function on this software that the sender applied. So how does the receiver know which hash function was applied by the sender? And the answer to that, once again, is the digital certificate, right? So the digital certificate that was downloaded, not only did it have the public key of the sender, but it also had information about the hashing algorithm that the sender uses, right? So through the digital certificate, the public key is also available, the public key of the sender is also available, and the hashing algorithm is also available, right? So the receiver applies the same hashing algorithm on the software, and it gets a hashed value for the software. The receiver also calculates the hashed value of the software, and once again, this hashed value is called a digest. Okay, so this is basically the hashed value of the software. Now remember, the sender also sent you the digital signature, and the digital signature was what? It was the encrypted hash value. It was the encrypted hash value of the software, right? This was the digital signature in this scenario, right? The software was first, a hash value of it was calculated, and then it was encrypted. Okay, so now you have the encrypted hash value of the software, which is called the digital signature. That digital signature, that encrypted hash value, is decrypted. It is decrypted using the sender's public key, right? So and remember, the sender's public key is available through the digital certificate, right? So the sender's public key is used to decrypt this digital signature, right? And what do we get? Once we have decrypted it, we get the hash value, right? Because the hash value was encrypted. Now we decrypted it, and what we have available is the hashed value that was sent by the sender. So remember, this was sent by the senders. So this was sent by the sender, right? And this hashed value was calculated by the receiver, right? This was calculated by the receiver. So once again, you received two things. You received software and you received digital signature. The software, for the software, its hash value was calculated, and we have that available to us, right? So the receiver has calculated the hash value by himself, and the receiver also received the digital signature, which is the encrypted hash value. The receiver decrypts the encrypted hash value using the public key of the sender, and it now has the hashed value that the sender sent in unencrypted form or in plain text form. So he has the hash value available. This hash value has been decrypted, and what the receiver does is it matches its own calculated hash value with the sender's hash value. If both of these match, that means two things: that the sender is genuine, and it also means that the software has not been altered. I hope the concept is clear now. Okay, so what I've done is I've copied the answer from the marking scheme, and you can just go through it, and hopefully this is going to make sense to you.